Hello students, welcome to AIMS online classes. This is chemistry session. Now we're going to see about the chapter acids, bases and salts. From this chapter, let us see about pH scale. A scale for measuring hydrogen ion concentration in a solution is called pH scale. The P in pH stands for potence, which means the power. pH value of a solution is simply a number which indicates the acidic or basic nature of a solution. Okay, here P represents the power of hydrogens or potence of hydrogens. This pH value of a solution generally indicates the acidic or basic nature of the solution. It is just a number. We know that all the acids and bases do not react with the same chemical compound at the same rate. Yes, some acids react very vigorously, and some acids they react moderately, and some acids they react very slowly, and even some acids they may not react at all. So the nature or of acids differ from one to another. To determine the strength of acids and bases quantitatively, we use an universal indicator which shows different colors at different concentration of hydrogen ion in the solution. Yes, we use an indicator which is called universal indicator to determine the strength of acids and bases. This universal indicator will show different colors with different kinds of substances. It will show different colors with the acids, it show different colors with the bases, and even with the neutral solutions also we show different colors. So by using this we can identify the strength of an acid and base. Even with the different acids it will show different colors. Based upon the strength of the acid, the color shown by universal indicator varies. Generally the value of pH of an acid or base are used to quantitatively determine the strength. Yes, even pH value also will indicate the strength of the either acid or base. Mathematical definition of pH is a little less initiative but more useful in general. Yes, it states the pH equals to the negative logarithmic value of the concentration of hydrogen ions. So if we know the concentration of hydrogen ions in a solution, then we can determine its pH value by taking the formula negative logarithm of H plus n concentration. So by knowing the number pH, we can determine its acidic or basic nature as well as its strength also. Yes, mathematically it is represented like this. pH is equal to minus log of H plus ion concentration. So if we know the H plus ion concentration of a solution, then we can find out the pH of the solution by using this formula minus log of H plus ion concentration. If we know pH value, then we can determine its exact quality, either it is acidic or basic or the strength of its acidic nature or basic nature also we can determine. The pH of neutral solution is 7. The value less than 7 on the pH scale represent an acidic solution. As the pH values increases from 7 to 14, it represents a decrease in H plus ion concentration or an increase in the OH ion concentration in the solution. That means basic nature. The pH value of a solution above 7 represents a basic solution. Yes, from this you can say this pH scale ranges from 0 to 14. 1 to 14 we can say. The pH range in between 1 to 7 indicates acidic nature of the solution. As the value of pH decreases, acidic nature increases for the solution. If the pH value is above 7 and in between 7 to 14, that represents the basic solution. As the pH value increases from 7 to 14, basic nature of the substance will be increased. If the pH value is exactly 7, then we can say the solution is neutral. See here pH scale is shown. If the pH value is exactly 7, those substances are said to be neutral solutions. Example, pure water. Pure water is a neutral solution or neutral substance. Its pH value will be exactly 7 if it is identified. It shows a light green color with a universal indicator. It is shown here. And the pH values in between 7 to 1 represents acidic substances. As the pH value decreases, the acidic nature of the substance increases. Say gastric juice or HCl, its pH value is around 1, means it is strong acid. And the milk is lightly acidic, its pH value is around 6. So in this way, the pH range in between 1 to 7 represents an acid. As pH value is low, the acidic nature increases in such a way. And the pH range in between 7 to 14 represents the bases. As the pH value increases, the basic nature also increases for the substance. See here, concentration solutions of alkalis like sodium hydroxide, potassium hydroxide, their pH values will be near to 14. That means they are strong bases. Okay. The strength of acid or base depends on the concentration of either H plus ions or hydroxyl ions produced in the solution. If we take hydrochloric acid and acetic acid of the same concentration, then they produce different concentrations of hydrogen ions. Yes, if we take a hydrochloric acid and acetic acid, these two will produce different concentrations of hydrogen ions. Yes, each acid will produce different kinds of concentration of hydrogen ions. All the acids they do not produce same concentration. Strong acids, we said already about what are strong acids. The acids which can produce more number of H plus ions are called strong acids. The acids which produce few amount of hydrogen ions are called weak acids. Here we told hydrochloric acid, which is a strong acid. And if we take acetic acid, which is one of the weak acids, if we take the same quantity of these two acids, the concentration of hydrogen ions will be more in hydrochloric acid, and the concentration of hydrogen ions will be less in acetic acid solution. So, different acids produce different concentration of hydrogen ions in their solution. So, acids that give more H plus ions are said to be strong acids. The acids which give fewer H plus ions are said to be weak acids. So, here hydrochloric acid is strong acid, acetic acid is weak acid because it produces less amount of H plus ions only. See here, if we take hydrochloric acid into the water, its solution produces more number of H plus ions. Most of the molecules of that acid will split into respective ions and form H plus ions and negative ions. If we take weak acids like acetic acid into water, very few molecules they ionize to form H plus ions and negative ions. Most of the molecules will be as it is, they won't be ionized. So these are called weak acids, and which will be ionized completely or almost are called strong acids. pH of acids and bases. The pH of a solution varies from 0 to 14. Yes, this is a scale which represents the pH of the solutions. pH scale ranges from 0 to 14. The pH scale range from 0 to 7 represents acids or acidic nature. The pH range from 7 to 14 represents bases or alkaline solutions. The pH exactly 7 represents neutral solutions. Solutions having a value of pH 0 to 7 uh, termed as acids, and the pH of ranging from 7 to 14 represents bases, and pH exactly 7, those solutions represents neutral solutions. Solutions having this value of pH equal to 0 are known to be strongly acidic solutions. Further, the acidity decreases as the pH value increases from 0 to 7. Whereas solutions with the value of pH equal to 14 are termed as strongly basic solutions. The basicity decreases as the value of pH decreases from 14 to 7. The strength of the acids and bases depends upon the number of H plus ions and OH minus ions produced by those solutions. Yes, based upon the number of hydrogen ions and OH minus ions, which are called hydroxyl ions produced by those solutions. The acidic or basic nature depends. Acids furnishing more number of H plus ions are known as strong acids, and the acids which produce less number of hydrogen ions are said to be weak acids. Okay, how to calculate pH of a solution? If we know the H plus ion concentration, we can calculate its pH value as follows. Let us see here. pH is determined by the concentration of hydrogen ions or H plus ions, which frequently summarized as H plus ion concentration. If the H plus represents in the square brackets, that represents the concentration of the H plus ions. This can be calculated by using the equation pH is equal to minus log of H plus ion concentration. So, if we know the concentration of H plus ions, we can easily calculate pH of that by using the formula minus log H plus ion concentration. Conversely, the hydrogen ion concentration can be found by the given pH value. Yes, if we know pH value is given, then we can find out H plus ion concentration from it by using the formula H plus ion concentration is equal to 10 power minus pH. So if we substitute pH value here, we will get hydrogen ion concentration. So we can do both in the reverse ways. If you know pH, we can calculate H plus ion concentration. If we know H plus ion concentration, we can find out pH by using this formula. For example, it is given a solid problem. Let us see here. Calculate the pH of 0.2 molar HCl. So here, what is the 0.2 molar representing here? Hydrogen ion concentration in hydrochloric acid solution. So HCl solutions are strong acids. So we can already expect a pH less than 7. Yes, as it is being acid solution, we know acids are having pH values ranging in between 0 to 7. As hydrochloric acid is one of the acids, its value will be below 7. Using 0.2 molar HCl concentration as a concentration of hydrogen ions, we can find out pH by using the formula pH is equal to minus log of H plus ion concentration. So if you substitute the hydrogen ion concentration as 0.2, we get it as minus, okay, can be taken like this, minus log of 0.2 because H plus ion concentration is given as 0.2 molar. We have substituted that. By that, if you calculate the value of minus log 0.2, we get it as 0.7. So a 0.7 pH indicates a very strong acidic solution. So what we have done here, they have given hydrogen ion concentration or acid concentration as 0.2. As it is a strong acid concentration can be taken directly as H plus ion concentration. So H plus ion concentration is given as 0.2. If we know H plus ion concentration, we can calculate pH value of the solution. How? We have the formula pH is equal to minus log of H plus ion concentration. So if you substitute the H plus ion concentration in the formula, we get pH value. Hope you know how to calculate the logarithmic values. So if you calculate the log 0.2, we'll get as minus 0.7. Initially it is a minus, so we'll get finally pH as 0.7. pH 0.7 represents that has strong acid because acid range is from 0 to 7 we know. This value is almost near to 0. So as the pH value reaching 0, the acidic character increases. As it is very near to 0, you can say it is strong acid. Okay, that's a way to calculate the pH values. Importance of pH in our daily life. Yes, pH has its importance in our daily life also. Let us see how it is. Plants and animals are pH sensitive. Yes, in their metabolic system, those fluids maintain a particular pH range. In that pH range only, those organs work normally. If there is a change in the pH values, they get some disturbance. Living organisms can survive only in a narrow range of pH change. Yes, when pH of rainwater is less than 5.6, it is called acid rain. Yes, generally water is a pure in the pure form it is neutral, but rainwater while coming from the sky to land it dissolves some gases like carbon dioxide and some other non-metallic oxides so that it becomes acidic in nature, slightly acidic. So its pH range will be around 5.6. So this that is called acid rain. When acid rain flows into the rivers, it lowers the pH of river water. The survival of aquatic life in such rivers becomes difficult. Yes, what happens as this rainwater is acidic in nature, it reaches the rivers and dissolve. So the living things or aquatic animals living in the water, they face some difficulty by consuming this water with pH range less than 7. Actually, if it is neutral, there is no problem. But when this rainwater dissolving these gases like carbon dioxide and some other acidic gases, this rainwater also becomes acidic. That's why you say this is acid rain. So when these aquatic animals consume this water, they may face some problems. Even if the pH range increases, sometimes the aquatic animals they may die also because of more acidic nature. Okay, that's one of the problems with the pH change. pH change causes tooth decay. Yes, tooth decay starts when the pH of the mouth is lower than 5.5. Actually, the mouth liquids like saliva, they may have pH uh, more nearby 5.5. If the pH is lower than 5.5, then we face some problems like tooth decay. Tooth enamel made up of calcium phosphate, which is a hardest substance in the body. Yes, this enamel is hardest substance, which is made up of calcium phosphate. It can it can survive till the pH value being 5.5. If it is being lower than 5.5, then this enamel may get damaged. It does not dissolve in water, food, but it is corroded when the pH in the mouth is below 5.5. Yes, if the pH value is below 5.5, then it starts getting decayed. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth. Yes, if any food particles like sugars and glucose they remain in the mouth, that starts increasing the growth of bacteria. This bacteria decreases the pH range in the mouth. If the pH range decreases below 5.5, then it starts decaying this enamel. The best way to prevent this is to clean the mouth after eating food. Yes. So we have to take care without remaining these food items in the mouth after eating. For that, what we have to do after eating the food immediately, we have to clean our mouth immediately so that there will be no remains of these food items like glucose and the sugars. Then there is no production of more acidity. Our enamel will be safe. Using toothpaste, which are generally basic neutralize the excess acid and prevent tooth decay. Yes, we use so many kinds of toothpaste which are generally basic in nature, slightly basic. So when you brush with the base paste, this neutralizes the excess acid present in our mouth so that tooth decay will be prevented. pH in our digestive system. Yes, it is very interesting to note that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. Yes, actually, what happens? Our stomach produces a gastric juice which is containing hydrochloric acid, which is one of the strong acids. But it helps in digestion of food without harming our organs, without harming our stomach. That is interesting thing here. During indigestion, what happens sometimes during indigestion, excess amount of this acid will be produced. Our stomach will produce too much of acid, and this causes pain and irritation in the stomach. To get rid of this pain, what do we do? People use bases called antacids. These antacids contain some bases. These antacids neutralize the excess acid in the stomach. Magnesium hydroxide, which is commonly called milk of magnesia. A mild base is often used in the form of antacids for this purpose. So what it will do? It will react with the excess acid produced in our stomach and it neutralizes that. So that we will get rid of this pain and irritation. Okay. Next, self-defense by animals and plants through the chemical warfare. Yes. Have you ever been stung by a honeybee? How do you feel if an honeybee sting us? We feel pain and irritation too. Bee sting leaves a small quantity of acid into our skin, which causes pain and irritation. Because this honeybee leaves some acid into our body, which is called formic acid. So this acid causes pain to us. Use of a mild base like baking soda on the stung area gives relief. So when you apply some baking soda on the sting area, this base reacts with the acid released by the honeybee and it neutralizes that. So that we will get relief from the pain. Stinging hair of leaves or nettle plant inject methanoic acid or formic acid causing burning pain. Yes, some leaves also release some this formic acid. We'll get immediately some irritation with that or pain or irritation with those nettle plant like. So then also we can apply this baking soda which is a mild base, lightly basic substance. So this react with those formic acid or methanoic acid to neutralize that. So that will get relief from that pain and irritation. A traditional remedy is rubbing the area with a leaf of dog plant, which often grows beside the nettle in the wild. Yes, this dog plant also is slightly mildly basic in nature. So if you rub that, we'll get relief immediately. Thank you for watching our video. Please visit our website aimstoday.in and subscribe our YouTube channel Aims Today for latest updates and recorded videos. Thank you.